If we look at question 4, if we compare these two set of data, we can see that PQ is constant, whereas Q2 increases by 4 times. And so the rate also increases by 4 times. So the order with respect to Q squared is 1. If we compare the next set of data, this and this, what we can see is that PQ is constant, but when the amount of PQ doubles and Q squared is constant, the rate also doubles. So the order with respect to PQ is also 1. So our rate equation is something like this. So with that, they ask you, what is the value of X? So if we compare this set with this set, what we are seeing is that we are seeing that the rate over here doubles. So the rate doubles. So what could have caused it? Let's look at the one on top. The one on top shows that when the rate increase, the concentration of PQ actually increases by 4 times. So if the concentration increased by 4 times, I will expect the rate to increase by 4 times, right? But it didn't. It only increased by 2 times. Why? Because X should be a value that is bigger. Okay, so X must be a value that is bigger than 12.5. So if we look at the solution, the answer is C, 25. So let's work out. Given that the answer is C, 25, now let's try to reason this part and this part. Okay, so this increases multiplied by 4 times. So rate should increase by 4 times. However, here it actually decreases by half. It actually was half, right? So the rate was increased by 4 times and then later half it, so it becomes 2 times. So it's supposed to increase 4 times, and then after that, the effect is that the concentration was half, so rate should also be half. So it will be 4 times 0.5, so actually only increases 2 times. So increases 2 times, so we can see, right, the rate actually increases 2 times, so it's correct. So answer is C.